Good morning. So, back in the mini macro today, which is now at version 1.2.1, released 12 days ago. And I'm just going to be kind of playing with some ideas. Oh, I wonder if he fixed this dialog yet. Nope. Okay, there's still a bug in how Linux is mounting new folders. So, I'll have to do this from the command line. Just a moment while I try to remember what that syntax was. Under Windows and Mac, the UI is functional right now. Those get tested more often. Linux is always last one to catch up. There we go. Alright, so the command line is mini micro xa664 USR to mount the user folder, and we're back. But the mini macro does not have an ls command. You have to type the dir command, as you would in Windows, which is fine. Now, I've got an idea stuck in my head, and it has to do with geometry. So today we're just going to play with drawing pictures. Been thinking about it like doodling. So, like doodling with code. Sometimes I just get ideas in my head and I want to play around with stuff. And I don't know if anything will ever come of it. But, yeah, we'll see. Trying to remember. Draw ellipse. That's what I want to pick on today. Left bottom width height. So a neat thing, talked about this before, about the mini micro. I mean, you can do like immediate mode programming right here in the REPL loop. Repeat, evaluate. What's the third one? REPL. Oh, I can't let that rest. Repeat, evaluate, print loop. Of course, P is print. That's what I was just doing. Which allows you to, it makes it a really good environment for learning to program, because you can do all this stuff right here in the command line. You don't have to learn about packages and namespaces and static objects just to get something on the screen. The neat thing about the way the mini macro setup its displays is that you can actually draw pictures to the screen also, which actually gives it a bit of a one-up over Python. There you go, just drew an ellipse right there on the screen. And that's basically the parameters are right there in the wiki. Left bottom width height, color, and pen size. So what we are going to do is make an object that encapsulates an ellipse. Try to decide if I want these to have default values or not. You know, I think I will, because we're going to mirror the function for the moment. And we want the ellipse to know how to draw itself. The draw function doesn't need any arguments. Like the draw ellipse function needs all these arguments to tell it how to draw the ellipse. But on our object, the draw function will be pulling from instance variables. Oops. That's better. And then on the main loop. And let's drop the city ellipse on the screen. Color red, pen size 2. Let's make it thicker. And then every time through the loop, we're going to do a ellipse.draw. Error while attempting to look up draw. What did I do wrong? Oh, here's what I did wrong. And also gotta create a new ellipse, and then you can make it, and then that returns the self that goes back into the ellipse variable. Also, I should clear the screen. Okay, let's try that. There you go, and it just keeps drawing a red ellipse on the screen kind of forever. And I think I'm going to try to attach this to the mouse. I actually want to attach a circle, not an ellipse. Basically every circle is an ellipse, but not every ellipse is a circle, because a circle is the same size in both directions. I'm going to subclass the ellipse. And the way we do that, I'm actually thinking about making another change, because I'm going to see if I can make a circle that's going to follow the mouse around the screen. But to do that, it really makes more sense for these objects to be positioned on their center. In which case, the left is x minus width divided by 2. And the bottom is y minus height divided by 2. Okay. And theoretically, that should make a circle. Let's see. Let's say that x is 50, y is 300, a little further across the screen. Radius will be 40. Let's make it blue. Pen size is 2. And I fed that the radius, which is actually width. I set width and height both to radius, which is actually wrong. The width and height should both be equal to the diameter, which is the radius times 2. And then we actually need to draw the circle. Line 21 is wrong because I forgot a comma. Let's try that. Can't look up draw, line 31. Oh. Need to actually return that. Otherwise your circle is null. And the is required on line 21. Because that is now a function, so you need the parentheses. There you go, there's a circle. And these are both going off screen now because I'm plotting them from the center instead of from the edge. Let's see if that looks better. It does. Now, I need to remember how to access the mouse position, because I want the circle to follow the mouse. There's an object for the mouse. It has some properties on it. Got the what mouse button is being pressed is if you call the button function with a button number. You got the X and Y, whether or not the mouse cursor is visible, which will be nice if we decide to replace the mouse cursor with something else. And mouse.locked. Why would you want to lock the mouse cursor? Interesting. I assume that freezes it, but I'm not sure. Look, how to detect single mouse clicks. Oh yeah. You check the status of the button, and you want to know if it's down now, but it was not down in the last frame, which means that it was released and now it's pressed. And then the frame after that, it'll have been pressed on the previous frame, the next frames, which means it's being held down. You don't care about it anymore. Anyway, this should move the mouse, or move the circle to follow the mouse. Of course, I haven't defined that function yet. Let's define it up on our ellipse. So defining on the ellipse means that we can now move ellipses and circles, theoretically, whenever we need to. Okay, let's go ahead and do that. Width is unknown because it's not width itself dot width. Okay. The circle now follows the mouse. Of course, you see the next problem we're going to solve. It is drawing that same circle over and over again. Now, if we're making a drawing program, that might be useful, but that's not really what I'm aiming for. So we can clear the graphics screen and see what that looks like. So of course, now you're seeing the next problem. Because it's clearing and then redrawing on the same screen every frame, it's gonna look kind of ugly. So we add in the double buffering. Oh, I was hoping it would just be listed there. Okay, that's fine. There is another package I'm going to pull in that will help with this. Is it TC? Oh. Yes. So, this is basically a shortcut function for writing these tweet codes. Basically, programs that you can fit into a Twitter post. But I like to pick on this one because of the flip function. Because I am a lazy programmer. I mean, I could write this myself, but it's so much easier to use the library function that writes it for me. So, I don't remember if we want to flip at the beginning of the render phase or the end of it. That looks good. So basically, we draw everything on basically an invisible off-screen display. Like, we have an off-screen display that represents the same chunk of memory that we're rendering, but none of it is going to be shown to the user yet. We clear that display, draw our circles on it, and then when we're done with all the drawing, we make the off-screen display the primary display so that now you can see it. So instead of watching all the drawing calls one at a time, the whole thing just kind of appears. So that it looks like we have smooth rendering now. And next up, I want to see if we can use the mouse wheel to grow and shrink our circle. For that, we need to add another function here. Two functions, to get the radius and to set the radius. I'm putting this on the circle instead of the ellipse because I don't care about the radius of the ellipse. So the mouse, if you want to get the button, press on a mouse do mouse dot button, and then as that which parameter. So let's find out which value is the mouse wheel. We're just going to check all of them. Well, the first 5. Counting on computers always starts from 0. Which not found in map, because it's not called which. It's called button. You can see when I press the left mouse button that flashes. The right mouse button is flashing. And the mouse, clicking the mouse wheel does something. Scrolling the mouse wheel does nothing. Oh no! Can I not capture the mouse wheel? It's possible that that functionality has just not been captured yet. Mini Micro is still a work in progress. For being 1 to 6, let's capture 4, 5, and 6. I think for that we need to import the string util to use that fill function. No, I thought that would do something. Three, 4, 5, 6. Let's try that. Okay, we're going to diagnose this right quick. So that map 0 is the left mouse button. 1 is the right mouse button. 2 is the middle mouse button. 3 is nothing. Okay, so we have 0, 1, and 2, and that is it. Let's see. Axis. I mean, there's key axis, but I don't think that applies to the mouse wheel. And there's an input check demo, so let's try running that. Okay, so there's the scroll wheel. It appears to be stored in one of the axes. Mouse scroll wheel. So let's try capturing that. I think that was what it was called. And there we go. The scroll wheel is now doing a thing. We're going to store that, and if you scroll the mouse wheel, we're going to change the size of our circle. Oh, what did I do wrong there? Get radius is a function, returns width divided by 2, set radius. We'll just set the radius. Get radius not found in map. Because why? Now my theory is that the circle thinks that it's an ellipse. So instead of returning the ellipse.make value, we're going to return the self from the circle. And yep, there it goes. Mouse wheel can now modify the radius of our circle. Okay, I'm going to pause here. I think next video I'm going to work on being able to modify, like move around multiple shapes at the same time, and maybe do some stuff with lines. I keep doodling with this for a while and we'll see where it goes. And that's all for today. See you later.